Good morning, everyone. This is Barry Tonning from Tetra Tech. I'm the moderator for this case study session. I think we're still waiting for Reed to join. So let me just make a couple of quick housekeeping announcements here, and then we'll start the video and get the session underway. I did want to remind everyone to please mute yourself to make sure there are no background noises distracting from the presentation. Also, if you have questions, use the chat box. If you have any AV issues, also you can use that chat box, and Liz Hyatt, my colleague from Tetra Tech, will deal with those. You have three dots at the top of your control panel there. There are a couple of selections that can enlarge the image if you're having trouble seeing the slides or the video. There's one called focus, and there's another selection called full screen. So you might check those out. Um, also, we will be sending out an evaluation survey at the end of the day. I encourage everyone to fill those out. It really helps us to update the presentations and update the topics for the next session. And then finally, there's a resource page with a lot more information on the permit, the minimum control measures, and case studies and other interesting information for MS4 managers. I see that we do have Reed logged in now. Welcome, Reed. Welcome, Laurel. We're going to hear their case study on the Fox Run Floodplain Restoration Project. And I think we kicked this off with a video. Is that right, Liz? Are you going to cue that up?
Yes, I'm going to do that right now.
All right, cross your fingers and here we go.
The Fox Run floodplain restoration sits at the heart of Dover Township's new Eagle View Park and delivers a host of regional benefits. Floodplain restoration is a multifunctional best management practice that can provide stormwater management for proposed development, pollutant load reductions for MS4 obligations, flood mitigation, educational and recreational opportunities, and extensive ecological uplift. The property, a former golf course, was purchased by the township in 2011 with visions for a future park. The two tributaries to Fox Run flowing through the property were identified as potential restoration project in York County's Regional Pollutant Reduction Plan in 2017 because of the severely degraded condition. Understanding the community's goal for a future park, Dover contracted Land Studies in 2017 to conduct a feasibility study and assess the potential to achieve both pollutant load reductions and meet stormwater needs for the park through a single floodplain restoration project. Land Studies ultimately provided design permitting, grant writing, and construction management services to achieve regulatory authorization, secure funding, and construct the restoration, which was completed in October 2020. The restoration resulted in the removal of 27,000 cubic yards of legacy sediments from the floodplain to restore the historical ecological function and capitalize on the associated benefits. The restoration provides sediment load reductions of 154,387 pounds per year by eliminating problematic erosion and encouraging beneficial ecological processes. The project also meets stormwater peak rate and volume requirements associated with up to 10 acres of impervious development associated with Eagle View Park, and was also demonstrated to replace the function of an existing regional basin on the adjacent parcel, which will now be removed to accommodate a future road extension and associated economic development. The legacy sediment material was utilized on site to create a 10-acre pad for the proposed park improvements, which include a playground, parking lot, ball field, pavilions, and a walking trail. In addition to the community benefits, the project also provided substantial ecological uplift by restoring 3,440 linear feet of degraded stream channel, creating nearly 5 acres of wetlands, and establishing over 10 acres of native wildflower meadow buffers. These habitat improvements will provide recreational and educational improvements for parkgoers and students at the adjacent Dover Area Middle School. Utilizing a single best management practice to serve multiple purposes helped the township to save money compared to traditional best management practices. And leveraging the extensive benefits to attract diverse funding sources helped to truly minimize costs to the township. Dover was awarded $1.49 million from DEP's Growing Greener for floodplain construction. The York County Stormwater Consortium contributed $605,000 to relocate an existing sewer line to accommodate the improvements. And just recently, the township received $250,000 to fund the first phase of park improvements. The floodplain restoration was completed in fall of 2020, and park improvements are scheduled to commence in summer 2021. Dover's long-term planning and regional outlook were critical to achieving these successes, and those are the keys to applying these same concepts in any community.
Okay, thank you for playing that. We are going to get the presentation up on the screen now. And while Reed's taking care of that, I'm gonna wish everybody a good morning. And on behalf of Land Studies in Dover Township, we would like to thank the providers of this MS4 forum for inviting us to review our project for the good of other communities in Pennsylvania. We are very appreciative of the opportunity to talk about our Eagle View Park and its connection to the MS4 program. If we can go to the first slide.
Are you seeing the slideshow?
Yes.
Everything's going all right. Take it away.
Go to the next slide there. Okay. Our presentation has three main parts. As the township manager for the last 15 years, I've had the unique perspective of being here since the beginning of the discussions about the projects that are part of the Dover story. It is a tale about how we have leveraged a public works, garage expansion, golf course purchase, and the floodplain restoration as the starting place for the community's largest park. Reed Garner of Land Studies will present the two remaining parts on discussing what legacy sediments and floodplain restorations consist of, as well as the value realized from these types of projects. Next slide. For point of reference, Dover Township is a township of the second class with approximately 22,000 residents and growing, and 5 elected township supervisors. The floodplain restoration project was completed on the property of a golf course known as the Old Mid-Atlantic Driving Range, which is located to the rear of the municipal offices and Dover Middle School. The middle school is located in Dover Borough. Therefore, Eagle View Park is a truly unique opportunity to provide stormwater capacity and recreational opportunities for all 3 entities. Dover's story starts with the township purchasing an executive golf course in 2011 with the visions of a future community park. Through various hurdles, a floodplain restoration initially proposed to address Chesapeake Bay pollution reduction program requirements helped tie together many diverse community goals and interests. The restoration helped meet MS4 obligations, provided stormwater for a new park, enabled construction for a new township road to accommodate school bus traffic, provided material for the park pad, and eliminated the need for a regional basin, which accommodates a 1.5-acre addition of potential commercial development near State Route 74 in the township. Next slide. In 2011, the township purchased the Mid-Atlantic Golf Course to provide for future open space and expansion of the municipal complex. However, after this purchase began, we began to see a slowdown in residential development, as well as a change in our elected official makeup. From 2011 to 2016, the entire 5-member board of supervisors changed. The staff needed to build relationships with the newly elected officials to explain the operational needs of the community and its personnel as we continue to grow in population. Fortunately, during that time, development also began to pick back up, and projects unlikely to be funded by grants became more palatable. In 2016, the York County Regional Stormwater Consortium, made up of about 40 municipalities, was looking for projects to meet the new pollution reduction program requirements of the regional municipal separate storm water system permit. From 2018 to 2023, the permit will require projects to be funded to meet these pollution reduction goals. Dover Township, due to the funding model adopted by the consortium, would pay $202,000 per year to fund these projects, which equates to about $1 million over a 5-year project or a 5-year permit cycle. The Fox Run floodplain restoration project would allow the township to see a return of those monies to the community by funding a much needed project. We made use of our contract with Land Studies to determine if a regional stormwater pond located on the adjacent commercial property and the park's stormwater system needs could be combined with pollution reduction goals, as well as reuse of the nutrient-rich sediment from the floodplain project to be used to regrade the parklands. Dover Township, with aid of Land Studies, applied for and was denied 4 other grants for the floodplain project from PennDOT's Transportation Alternative Program Grant and the Department of Community and Economic Development's Greenways, Trails, and Recreation Program, their Floodplain Restoration and Protection Program, and their Floodplain Mitigation Program. In 2018, we made the decision to self-fund the design and permitting for the floodplain project at a cost of approximately $185,000, which was used to successfully provide match to the DEP Growing Greener grant. We committed to a design-build approach with Land Studies, which was the approach favored by the grant program. This project attracted about $2.5 million in funding from diverse state, local resources, minimizing the cost to the township for the park's future development. Next slide. These are the existing conditions on the property pre-floodplain restoration. The stream was a liability with its steep banks, exposure of its sewer line that traverses through the land, and the excessive erosion. Next slide. Our project kicked off with the construction beginning in May of 2020 and finishing the earthwork in late September. Planting and seeding continued in the fall. Considering the circumstances that we all faced in 2020, this project was a pleasant surprise for how well the contractor and consultant were able to meet the timelines and complete the work within budget. Next slide. This was the original concept plan prepared by Land Studies with the feasibility plan. Dover Township leveraged multiple capital projects needs with the purchase of the golf course and strategically developed those concepts to obtain grant funding for this project. We began with adding the park land of 49 acres to the township building parcel of 8 acres to create 1 lot so that we could proceed with the garage expansion between 2017 to 2018, which was sorely needed due to population growth. Additionally, in 2017, Land Studies was contracted to prepare this feasibility study to aid with our York County Regional Stormwater Project that was in the reduction plan to restore a smaller portion of the floodplain along the tributary. The feasibility study results actually demonstrated the potential for both pollution reduction and stormwater management benefits from floodplain restoration to be completed on the entire parcel. The first circle that you see there in blue is the floodplain restoration area. This blue shaded area shows that the floodplain footprint serving for both the pollution reduction project and the stormwater management best practices. The restoration achieved sediment reductions of 154,387 pounds per year. Second circle, the floodplain restoration will also replace this regional stormwater pond, which is located on 9.22 acres of land along Route 74. That will add an additional 1.5 acres of potential economic development to that area, and it was a key component part of getting the landowner to allow for a road that we intend to put through to Route 74 as an alternative route, which was part of a joint comprehensive plan initiative between the borough and the township to create alternate routes around the borough square. In addition to replacing the capacity of the regional basin, the restoration also provides stormwater benefits for the proposed park improvements. We were also able to reuse the legacy sediment material excavated from the floodplain to create a well-drained 10-acre pad for the park. The grading plan for the park pad also utilized a large temporary soil stockpile left over from the construction of our new municipal garage facility that we would have otherwise had to pay to remove. The floodplain design included an outdoor classroom on Dover School District's property, as well as bridge crossings that would be part of our over 3,000-foot trail system connecting large residential areas in Dover Township to the school district and the borough. This park will be a tremendous resource for the community due to its proximity to the school and borough. Regional events will be able to be held with ample parking within walking distance by making use of the school district's facilities. Next slide. These are before and after photos. The circles that you see on both sides are points of reference where there are trees that remained after the project was complete. Dover Township made the decision to self-fund the design and permit for the floodplain project because we were rejected for 4 other grants. We weren't prepared to move forward with the project. They weren't deemed shovel ready. So by moving forward with getting the permits and design in place, we were better able to be funded by DEP. The commitment of that $185,000 for design and permits and to the design build process made us successful at obtaining the Growing Greener grant for the floodplain restoration, and it was the catalyst for all other funding. Thus far, Dover Township has leveraged the $1.49 million in DEP money to obtain $250,000 in DCNR money for phase 1 park improvements consisting of trail installation, an outdoor classroom, disc golf, educational signage, and a pavilion with a fireplace. The $605,000 from the York County Stormwater Consortium to relocate our sewer main out of the historic floodplain footprint was also received. And just recently, we received word that we are receiving a $200,000 grant from the Pennsylvania Department of Community and Economic Development from their Greenways Trails and Recreation program to fund additional trails and the pedestrian bridges. We have recently submitted for another $250,000 DCNR grant for our adult baseball field, trails, and parking facilities. If you could see, wait, go back a minute there. On the slide on your right, between the 2 trees, that is where the pedestrian bridges will connect the school and the township's park, and there will also be educational opportunities for the students in that area for them to do their stream studies, which they've historically been doing for years, but this is going to be a much better way for them to do that work. Next slide. All of this is without mentioning the environmental and less tangible benefits we created. Acres of wetlands. We already see all sorts of birds, including the aptly named bald eagle at Eagle View Park. As the vegetation becomes established, it will be a huge aesthetic enhancement at the center of a park rather than the eyesore and potential liability that it once was. With the floodplain restoration and this big picture planning approach, we were able to get a lot of major benefits from one project. The rest of this presentation will go in depth into the understanding of the history of streams and floodplains and is key to being able to realize the benefits of this restoration approach. Now I'll turn it over to Reed.
Thanks, Laurel. Messing with my mouse here, getting a little slowly with the wheel, so excuse me if the slides jump around. But that was a big picture summary of Dover's journey to initially they acquired this property with thoughts of maybe it's a future park. They had some hesitancy from the board of what we're going to do with it, and eventually the stream on the site was identified for a PRP project, which through our feasibility study we identified, yes, you're able to achieve substantial pollutant load reductions from this floodplain restoration BMP. And that's the primary driver of this project, the initial driver for the township, and kind of everyone's goal here today. How do we meet our MS4 requirements? What's the best way to go about getting these pollutant load reductions we need for our PRP? And there's no magic bullet, but I will say that the floodplain restoration BMP is capable of achieving substantial load reductions, which we'll get into later. And as you can see from Laurel's talk, There are a host of secondary benefits that can provide for a community. So it makes sense in a lot of cases, but it all starts with looking at the big picture and seeing what your community needs are, not just in terms of how many pounds do we need to reduce of sediment, suspended solids, but we have this requirement we need to meet, and how can we make that work within the other goals and the growth of our community, I think is the biggest takeaway. If you take away anything, it's start at the watershed level, start at the regional level, and see how you can make these projects work for you. They shouldn't be viewed as this unfunded mandate, which a lot of it is driven from the federal level and came down to the municipal level and said, figure it out. But there's also a lot of opportunity there, and there is a lot of diverse funding sources, as Laurel got into. I think there was a new grant you just mentioned that got awarded that I wasn't even aware of. So
yeah, it was just late last week.
Money from Growing Greener, money from DCNR, money from DCED, and money from the county's regional plan. So I'm going to kind of rewind a little bit and give you some more detail on what is this BMP, what's floodplain restoration, and it has to do with legacy sediments that are historical anthropogenic impacts to our floodways that occurred during and since European colonization of the country. That's a big deal in the Mid-Atlantic region, and particularly Pennsylvania, and get into the economic value. So restoring our ecological systems is great, but what's the value of it and where's their benefit in that? So floodplain restoration is looking at the entire floodplain system and trying to restore it as closely as possible to its historical condition. And the reason we do these things is because there's benefit to it. We can address erosion and sediment and nutrient loads. We can create a more stable footprint. We can protect infrastructure. Maybe we want to reduce flooding or achieve stormwater management. So in terms of floodplain restoration, it's looking at the impairments to a waterway and addressing those impairments. So traditionally, you might think of it, well, it's a point source discharge pollutant loading, or it's new development and there's increased runoff. But realistically, in the Mid-Atlantic and especially in the Susquehanna Valley, legacy sediments are one of the biggest impairments facing our waterways. And what legacy sediments are fine sediments that were mobilized from historic intensive land uses and end up in our valleys that clogged our waterways that used to be these vast, wide floodplains with small anti-branching channels connecting these big wetland complexes where there wasn't any clearly defined entrenched channel, but instead a big wetland stream floodplain complex where in storm events, any sort of rainfall event, that floodplain would be full and mitigating stormwater flows and reducing energy and allowing pollutants to fall out on the site. And that's historically how our floodplains functioned up until some of our impacts from settlement. So to understand the story of legacy sediments, you have to understand the story of the region and of Pennsylvania in particular. So when the state was first colonized, almost immediately land clearing through slash and burn timbering started and occurred across the state. The whole state was cleared of its trees, and they were an economic resource. The wood from Pennsylvania helped build the country. And it was also a way to clear land for agricultural pursuits. So in Pennsylvania, we have a really storied history of using our natural resources as best possible and as efficiently possible to get the most value out of them when they're valuable. And 300 years ago, this was harvesting our timber and turning that land into valuable agriculture. But what this resulted in is this mass mobilization of upland sediments and fine material So you don't have vegetation slowing runoff, so you have increased runoff events, and all this material is mobilizing from the hill slopes down into our valleys. And this was coupled with extensive and ubiquitous mill damming of our rivers. And if you look on the right side there, you see a partial list of the different types of industries that were fueled by mill dams. And for several hundred years, this was the primary source of mechanical power and a true economic driver. Any real city, town, community needed to have a mill dam to power its economy. The way these mill dams work are by damming across the valleys to create a ponded backwater, and that will bleed off to a mill race and power these milling operations. So you have this mass upland erosion from land clearing coupled with these dams being built throughout the state. And all those sediments end up in these mill pond dams and eventually fill up the dam. And what actually happened was, as those ponds would fill up with sediment, the water is compressing those sediments, and there's more sediments accumulating on top of it, and you get this really thick clay layer that you can see in this photo. So that dark brown black layer at the bottom of that photo is actually hydric soils. Those are wetlands. Those are an indicator of that's the historic floodplain. And over top of it, you see that light brown ubiquitous clay legacy sediment layer. So since the start of the Holocene, since the end of the last ice age, essentially, that thin organic layer was stable enough and sufficient enough to accommodate any flood flows that would have occurred without aggrading or degrading past that 6 to 8 inch layer. And then research that's come out of F&M, Dr. Walters and Merritt's have been real pioneers in the study of legacy sediments within the region, have done carbon dating that'll show this organic layer can be anywhere from 400 to 6,000 years old, say. And if you do a carbon dating profile of that legacy sediment material, it's all deposited within the last 300 years or so, since whenever a dam was constructed in that area. And what happens with these dams is, when you think of a mill dam, you think of something massive and structural. And this is an extreme example. That was for a hydroelectric dam actually built in the 1900s that failed 26 years later. And you can see the remnant legacy sediments after just that short time. But it wasn't always a massive structure. It wasn't just milling operations turning a water wheel. It was watering operations for agriculture and livestock. And when I say it was throughout the mid-Atlantic, it was extensive. So this is a map from Franklin and Marshall research, actually. It's data from the 1840 census that showed 60,000 active mill dams in the U.S. at the time. And you can see those red areas concentrated in the Susquehanna Valley, anywhere from 225 to 1,000 mill dams per county. And that's just one snapshot in time. So if you zoom in on the state, this is a map from a group called the Society for the Preservation of Old Mills that shows just how extensive these milling operations were throughout the state and the region. And again, this is just large mill dams that were powering a business. This doesn't account for localized dams that won't be counted on a census. I know there's questions about how accurate census counting is today in 2021. I can't imagine it was much better in 1840. So it was truly a prevalent condition, and it's seen throughout our streams. And this is what a lot of our streams look like today, whether it's in a forested reach or in an agricultural area with fewer trees on the banks. You see this entrenched condition where once those mill dams fail or are removed or not used anymore, there's an immediate drop in vertical grade control, and because they're these loose fine sediments with no stabilization, your base level control drops out and the stream incisors through whatever legacy sediments have occurred there. And more research is showing that our pollutant loading is not necessarily a function of the new development up the street not having proper ENS controls, or additional runoff from new impervious area, or improper agricultural BMPs. All of those things are an issue, but one of the biggest, and perhaps the biggest in the Susquehanna Valley, a contributor is stream bank erosion. And it's not necessarily from not having enough trees along the stream bank always. It's these impacts from intensive historical land practices that no one person is responsible for or caused, or no one group caused, but what we're all faced with dealing with the consequences. This next slide shows what our historical valleys would have looked like prior to these impairments getting filled with legacy sediment. So you'd have a wide flat floodplain that would have been a massive wetland complex, and there would be multiple channels that are able to move and meander naturally like a stream is supposed to, without causing severe lateral migration, erosion, and bank failure, or running into flooding issues. And if you look at the two next to each other, you can kind of get an idea of what's going on with these systems. So this basal gravel layer is rock material that deposited through colluvial processes at the end of the last ice age and formed the basis for these valleys. And eventually, thin layer of vegetation became established on top of this, and they served as a stable basis for our floodplains. And then once these legacy sediments became introduced, and you fast forward to today where there's dam failure and incision, these streams will either degrade back to a stable base level control. In some cases, that's a basal gravel layer, but in some cases, since it's such a confined channel, it's really almost pipe conveyance in these deeply incised systems. So you can get increased velocities that'll even punch through that basal gravel layer and weather into bedrock. And then you have a true disconnection of your hydrology sources. So traditionally, there is extensive groundwater held in these basal gravels. And when you have a legacy sediment impairment like this, it limits the amount of interaction between the stream and those gravel layers. And you don't have the same energy dissipation or anything. And all these legacy sediments were present on Dover's site. So we actually found this historical USDA aerial mapping that shows the apparent historical dam, and you can see the mill race coming through. And this was Quickles Mill. It was several mills throughout its history that would have impaired and impacted the whole site. And we found between 3 to 6 feet of legacy sediment across the site, depending on where you were at the downstream extents or further upstream in the watershed. To give you an example of the ecological impact, these hydric soils are an existing wetland that were on site. Here's our legacy sediment layer, and here's groundwater pouring out of the basal gravel layer at the historic floodplain footprint. So you have wetlands that are highly impaired and only fed by overland flow that could be connected to that floodplain hydrology. And you can see those wetlands in the pre-construction condition versus today when they're well connected to the stream and floodplain system. This whole area is wetland right now. So we've created almost 5 acres of wetland within that footprint. So that's what floodplain restoration is intended to address and what legacy sediments are. But now I want to talk about why it's valuable and what it did for Dover and what are some of the benefits in general. Here we go. So economic ecology is a symbiotic relationship between the environment and regional prosperity. And that can mean a lot of different things, but it's essentially improving water quality is our whole goal with all of these requirements. And if you can do that in a way that's sustainable and accommodates long-term budgeting and planning and growth, it's all the better. So in the case of Dover Township and the Fox Run floodplain restoration, this is what economic ecology looks like to them. We restored over 3,000 feet of this highly degraded and eroding channel. We created 4.5 acres of wetland within that floodplain footprint. We were able to quantify stormwater and peak flow and volume attenuation for this new park pad and for replacement of that regional basin that Laurel discussed. We quantified 154,000 pounds of annual sediment load reductions, which it was highly efficient compared to a lot of the other townships' BMPs. So the total project cost, which includes the construction of their new park, it's going to be starting this year, it was $2.8 million. We did an analysis to look at what would the cost be to do all these community improvements without the floodplain restoration. So to find alternative PRPs, we use the standard rate from all their other projects. So you have to find new sites. You have to do a lot of much smaller projects to get these same load reductions. You either have to import fill for this park pad or redesign to borrow elsewhere on site and do all this grading. So the cost with the floodplain restoration was actually $600,000 less than it would have been to do the park and these associated trails and roadway improvements without the floodplain, because we're taking all this legacy material and we're able to use it in a beneficial way on the park. And then when you factor in all the diverse funding the township was able to attract, their costs were $215,000 for this $2.8 million project. Now, that is missing some consultant design permit costs for the park, or design costs for the park that would have been factored in anyways, but you're looking at an incredible reduction in cost to the township that's going to benefit them in the future when they have that money to do other things with. So I'll jump into some of the more detailed oriented aspects of the benefits. The pollution reduction was 154,000 pounds a year. That's 77 tons per year of sediment reduction. And that's one of the unique things about floodplain restoration, where you're looking at it in terms of tons, not pounds. If this single project hit 71% of all the township's load reductions for their identified projects. Now, the average project identified in the regional PRP for Dover was about $11.50 per pound. When you do the math for the floodplain, it comes out at $11 per pound. So you say, what's the big deal? There's not much difference, but you got to remember that floodplain restoration costs included bridge abutments for this new trail system. We also incorporated removal and disposal of additional fill left over from their municipal project, detail grading for the park, trails, and a lot of ornamental upland landscaping that didn't necessarily contribute to their PRP. So when you look at it like that, the actual restoration cost was $6 a pound. And then the PRP projects in York County go through York County Stormwater Consortium. So Dover is one of the townships in this consortium, in this group, and they all work together to find the most valuable projects and fund the most valuable projects. Because Dover was able to leverage their own costs for design and permitting, the consortium had a much easier decision to make in terms of what they'd throw their money behind. So the cost needed from the consortium to finish construction was $605,000. So when you look at the cost to the regional planning committee, it was $3.90 per pound, a substantial reduction to the average PRP project that was going on in Dover. Another way to look at it is, even if you can figure out other PRPs that might be cheaper on a dollar per pound basis, you also have to think of your land resource. So this is a study that was published in the Journal of Soil and Water Conservation that showed floodplain restoration and legacy sediment hotspots they were looking at the same, achieving the same pollutant loads from different PRPs. So what they could do on 100 acres of floodplain would have required 4,800 acres of forest buffer. So you have to think of your space and the amount you have for this resource to devote to these types of projects. Now, when I talked about pollutant load reductions for Dover's project, we were talking in terms of standard default rates that we use to quantify those load reductions to maintain consistency with the PRP. But there's new guidance coming out for Chesapeake Bay expert panel protocols that are going to allow these types of projects to demonstrate even more substantial sediment and particularly nutrient load reductions, which is going to be the focus for the next round of permit cycles, and is a focus for the county action plans that some of your counties may already be part of. So I wanted to talk a little bit about that, and it also gives you good insight into how these processes work. So the protocols are prevented sediment, encouraging hypereic exchange, and floodplain reconnection to allow pollutants to deposit on site. So prevented sediment is essentially addressing these deeply incised channels that are vertical bare banks that are also conduits to allow for increased flow velocities. So when you remove that legacy sediment, you're eliminating the erosive condition by creating a flat, well-vegetated floodplain, and you're also dissipating all that erosive energy. So think of these legacy impaired systems like a blocked artery, essentially, where when that gets choked in, blood flow increases, velocities increase, and problems happen. It's the same thing that happens in these systems. The second protocol is hypereic exchange, which is flow between groundwater and surface water. When you're doing that, with floodplain restoration, you're tapping into this groundwater in the basal gravel layer, and that basal gravel layer is full of interstitial space that allows for beneficial microbial colonies, environments, and processes to take place that can, it's essentially encouraging denitrification. And if any of you have a wastewater background, the process is actually very similar in concept to a trickling filter, where you are dispersing effluent across a highly porous media where water slowly percolates and a biological film develops that processes pollutants. And our waterways historically did the same thing.
Got just a couple more minutes, Reed.
Okay, I can jump through here. And the third protocol is floodplain reconnection, where you are making the stream sit in close proximity so increased flow events can dissipate across that footprint, dissipating energy and allowing water to fall out on site. So this transitions nicely to the stormwater benefits of floodplain restoration. So when you have that increased footprint, you can achieve really substantial peak rate reductions and volume attenuation. So this is transducer data from one of our other restorations measuring incoming flows to Brewbreaker Run floodplain restoration in orange and outcoming flows downstream in black. And you see it's over cutting the peak rate in half. And this is something you can use to quantify for your Chapter 105 stormwater requirements associated with development. But it also gives you a really good idea of the flood mitigation potential, and it's going to be a big deal, especially, and there's a lot of money out there in Pennsylvania. There's flooding is a huge deal. Once you get to anything bigger than, say, a 1 or 2 square mile system, and big systems, you can't address and mitigate flooding through volume attenuation. You need to address the peak rate and lower the peak rate. And restoring your floodplains is a great way to do that. So floodplain restoration is a recognized and one of the less understood and most ignored stormwater BMPs in the manual. These are the reductions that we were able to demonstrate using two-dimensional HEC-RAS modeling, where we build a post-construction hydrograph, run it through the proposed floodplain corridor, and are able to quantify those peak rate reductions. So just to jump back to all the benefits that the township was able to get from this project, they used the floodplain restoration as a stormwater and pollutant reduction BMP. It enabled them to remove this regional basin that's going to add 1.5 acres of commercial development for this landowner, which when you're increasing your density like that, you're increasing your tax basis. Being able to work with the regional developer also enabled them to build this road, which is going to be used for bus transport to and from the school. So right now, the only way to the intermediate school is through one of the two primary roads in the community. If there's an accident or something, the whole school drop-off system is out of touch. So it goes back to this concept of building resiliency, where being able to build this road is going to accommodate, emergency traffic and school traffic around the current square in town that they're all relying on. The legacy sediments were used to develop and build up this park pad. So they have a very hilly site that had maybe 2 acres of buildable space, and we were able to create a 10-acre park pad. So there's just a lot of benefits they got. And when you look at the dollars and cents, they're saving $600,000 compared to the alternative cost, and they're able to leverage their investment and their goals to reach out to these diverse funding sources that are also getting benefit from it. So if you're meeting your PRP requirement, you might still be able to get funding from NIFWIF, who's not necessarily looking to fund a PRP requirement, but is looking to fund wetland creation and ecological uplift. Or you might be able to leverage that fund like the township did for DCNR recreational grants, and really start to stack benefits and leverage benefits to do something that's economically feasible and can vastly out-achieve any individual alternative BMP that you'd have to look at. So that's everything we have for you. I just want everyone to take away from this that floodplain restoration is a community planning tool, and it's just one of the tools. But when you're thinking about these systems and looking at these systems, think about the big picture for your region. So with floodplain restoration, you can achieve pollutant reductions and stormwater management, but also when you're able to do mass load reduction with a single project, you're making it so much easier to maintain. You don't have 50 rain gardens you have to run around and check on after every stormwater event. You have one natural system that after the vegetation established is essentially no maintenance. It's a natural system that's self-maintaining. That in Dover's case, they have a lot of educational and recreational benefits because it's at the center of this park and it's connected to the school system. It's creating these pedestrian safe routes to school. And in a lot of cases, this wasn't a focus of the project in Dover, but flood mitigation, being able to reduce that peak rate, spending a penny of prevention to eliminate the potential for a pound of flood recovery is a huge deal. So I left our contact information on this last slide. Please take it down. If you have questions, don't hesitate to reach out after this. I know we went a bit over, so if we run out of time for questions here, please shoot me an email or give me a call and ask away.
Yeah, thank you so much. We are out of time. The next session starts in about 1 minute. So please do take down the email addresses there for Reed and Laurel. That was an excellent presentation. So much involved there with floodplain restoration, a park, a road, trails, disc golf, bridges. Yeah, just an amazing project. We really do appreciate it. Thank you both. And again, we're going to leave this slide up for just another second or two here so people can take down your contact information and contact you offline here. We are moving to the 11 o'clock session right now. So thanks again, everyone, and we'll see you over at the next link. Thanks again, presenters. Take care.
Thank you all.